Hello everyone, today I'm with you a new concept called partial differential equations, or we call it as PDE. In this video, I will be explaining the concept of formation of PDE. Also, I'll be uploading more videos related to partial differential equations in upcoming videos. So if you have not subscribed my channel yet, subscribe this channel to get more videos which I'm going to upload later on. Similarly, if you like this video, give me like button in the YouTube channel. Before discussing or explaining formation of PDE, let me explain some basic concepts related to partial differential equations. Many problems in vibration of strings, heat conduction, and electrostatics involve two or more variables. Analysis of these problems lead to partial derivatives and equations involving them. That is partial differential equations. What is the definition of partial differential equations? A differential equation involving one or more partial derivatives with respect to differential equations, or simply a differential equation which involves partial derivative term is called as partial differential equations. For example, look at the first example. Dou square z by dou x square plus dou square z by dou y square is equal to 0 is an example for PDE. Here dou square z by dou x square as well as dou square z by dou y square are partial derivative terms. Look at the second example. X into dou z by dou x plus y into dou z by dou y equal to x square plus y square. Here dou z by dou x and dou z by dou y are partial derivative terms. Now, what is order of PDE? Likewise, order and degree exist for ordinary differential equations. Here also for PDE also order and degree is there. So what is the order? Order of the highest order means order of the highest derivative term in the partial differential equation. What is degree? Degree of PDE means degree of highest order derivative term. Homogeneous PDE. What is homogeneous PDE? Each term of PDE contains either dependent variable or one of its partial derivatives. So dependent variable means usually we see in the numerator of the derivative term. Then independent variable we see in the denominator. So in homogeneous PDE, in one expression, we should not have more than one independent variable in the denominator. Let us see some examples. Look at the first example. Dou z by dou x plus dou z by dou y is equal to 0. So what is the order here? Here order of highest derivative, first order derivative is here. Here also dou z by dou x as well as dou z by dou y first order derivative. So its order is 1. So what is the degree? So order of this first order derivative, that is power of this degree of this first order derivative is 1. So it is degree is 1. Since in first expression, that is dou z by dou x, we have independent variable only x in denominator. In second expression dou z by dou y, we have only one independent variable in the denominator. So it is homogeneous PDE. Now dou square z by dou x dou y is equal to xy. So what is the order of this differential equation, this partial differential equation? Here dou square second order partial derivative is there, therefore order is 2. Now what is degree? So what is the power of the second order? Dou square z by dou x dou y whole power 1 only, therefore its degree is 1. Whether this is homogeneous or non-homogeneous, since in the denominator we have more than one independent variable, so this is non-homogeneous partial differential equation. Similarly, dou square z by dou x square equal to dou z by dou y plus 2z. Here what is the order? Order is second order derivative is there, therefore this is second order partial differential equation. What is the degree? Its power is 1, therefore degree of this PDE is 1. Is this homogeneous? Of course, because in each expression denominator variable we have single denominator variable. Here x is only variable. In the second expression we have y is only variable. Therefore this is homogeneous partial differential. Now we will discuss formation of PDE, partial differential equation, by eliminating arbitrary constants. So in given equation, whenever arbitrary constant is there, so by eliminating that constant, how to form partial differential equations. Before that, let me give some notations. The following standard notations when z is a function of two independent variables x and y will be used. That means whenever z is equal to f of xy, only two independent variable, we use the following notations. So if you see dou z by dou x, that we denote it as p, or in short we denote it as zx. Similarly, dou z by dou y, that is equal to q, or we can denote it as zy. Dou square z by dou x square, that is second order derivative of z with respect to x. So this we denote it as small letter r, or zxx. Similarly, dou square z by dou x dou y, we denote it as s, or zxy. Likewise, dou square z by dou y square, we denote it as t, or zyy. So these five notations we have: p, q, r, s, t. So whenever z is function of xy, we denote these derivative terms in p, q, r, s, t. In next problems and all, we will be denoting by these notations only. Now let us discuss one example. Form PDE by eliminating the arbitrary constants in this given equation. What is the given equation? Z is equal to x plus a into y plus b. So what are the arbitrary constants here? A as well as b. So we have to eliminate a and b to find PDE. First, let us differentiate this given equation, that is z is equal to x plus a into y plus b, with respect to x and y partially. So differentiating. So if you differentiate this given differential given equation partially with respect to x, what we get? That is dou z by dou x equal to left side. In right side we have x plus a into y plus b. Since we are differentiating partially with respect to x, other than x, that is y variable, we have to take it as constant. Here y is constant, b is constant, so y plus b is full constant. So constant into variable. So this constant will not be changed. So I'll write y plus b into derivative of x plus a. What is the derivative of x? Partial derivative of x, it is 1. What is the derivative of a? A is constant, therefore 1 plus 0, that is 1 into y plus b, that is dou z by dou x is y plus b. Similarly, we have to differentiate partially with respect to y, that is dou z by dou y. Also we denote it as q. We have seen the notations. So dou z by dou x is p and dou z by dou y is q. So what is the dou z by dou y? In given given equation, we have to differentiate partially with respect to y. This time x plus a is constant. So constant into derivative of y plus b. Derivative of y is 1. Derivative of b is 0. So 1 plus 0, that is 1. So x plus a into 1. Therefore q is equal to x plus a. Now, so we have given equation z is equal to x plus a into y plus b. From equation 1 and 2, we have expression for x plus a and y plus b. This we will substitute in given z expression. That is z is equal to x plus a means it is q, and y plus b means it is p. So it is q into p, or pq. This is the required PDE. Now let me explain another example. Z is equal to a into log x square plus y square plus b. So given equation, let me take it as equation number 1. So here also we have to differentiate partially with respect to x and y. So first dou z by dou x, partially differentiating with respect to x, that is dou z by dou x. So what is the derivative of a into log x square plus y square plus b? So a is constant, so taken as it is, and derivative of log is 1 by x square plus y square into derivative of x square plus y square. Since here we are differentiating partially with respect to x, derivative of x square is 2x, derivative of y square is 0. Therefore, in numerator we have to multiply 2x. So it is 2 into ax divided by x square plus y square. So we'll rewrite it as dou z by dou x, we have notation p is equal to 2ax by x square plus y square. Let me give as equation number 2. Now let us differentiate partially with respect to y. Equation 1, we have to differentiate partially with respect to y. So what we get? Dou z by dou y equal to derivative of a is constant, derivative of log is 1 by x square plus y square, derivative of x square plus y square with respect to y partially is 0 plus 2y, because x square we are treating as 0. Derivative of y square is 2y. So it is q equal to 2ay divided by x square plus y square. Now we have to form PDE by using this equation 2 and equation 3. How we can form? We can choose any approach to get PDE. Need not be unique method. So you can approach in any way. So here let me divide equation 2 by equation 3. So what we get? P by Q, and this 2a from numerator and 2a from this equation 3 will cancel, as well as denominator of second equation as well as denominator of third equation also cancel. Here a will be eliminating. So what we get? P by Q equal to x by y. So one thing we should remember, here our aim is to eliminate arbitrary constant. So in this given equation, a and b were the constants that should not be there in our partial differential equation. So p by q equal to x by y, or py minus qx. Now let me explain another example. X square by a square plus y square by b square plus z square by c square equal to 1. In previous examples, we had only two constants a and b, but here we have three constants. One is a, another one is b, and another one is c. So whenever we have three constants, so just differentiating partially with respect to x and y is not sufficient. So whenever we have more than two constants, we have to go for higher order partial derivatives. So first let me take given equation as equation number 1. So first differentiate equation 1 partially with respect to x and y. What we get? Derivative of x square by a square will be, here 1 by a square is constant, derivative of x square will be 2x, plus y square and b square will be constants, so its derivative is 0 because we are differentiating with respect to x partially. Now z square by c square, here 1 by c square will be constant, derivative of z square will be 2z into dou z by dou x, that is 2x by a square plus 2z into dou z by dou x, we denote it as p, so 2z p by c square equal to 0. This is partially differentiating with respect to x. Now if you differentiate partially with respect to y, what we get? Derivative of x square by a square will be 0, since we are differentiating partially with respect to y. Derivative of y square by b square will be 1 by b square into 2y, plus derivative of z square by c square will be 1 by c square into derivative of z square is 2z into dou z by dou y, which is q. So we get 2y by b square plus 2z q by c square equal to 0. Now, so 2 is common, so we take outside and cancel with right hand side. So we get x by a square plus zp by c square equal to 0. Let us give it as equation 2. Similarly, y by b square plus zq by c square equal to 0. Let us denote it as equation 3. Only these two equations are not enough because we have three constants a and b. So we differentiate further partially. So differentiating equation 2 partially. We can differentiate either equation 2 or equation 3. I have choose this equation 2 to differentiate to get the PDE. So what we get, see. So what is the derivative of x by a square? Derivative of x by a square. Again, we are differentiating with respect to x. Remember, x is variable, so x derivative is 1 by a square plus 1 by c square into derivative of zp. Remember, z is variable, p means actually dou z by dou x. Therefore, this is also variable. So here to differentiate dou z by zp, we have to go for product rule of the differentiation. So what we get? 1 by a square plus 1 by c square into derivative of zp means z into dou p by dou x, that is first function into derivative of second, plus second function, that is p, into derivative of z, that is dou z by dou x, which is p. Here right side it is 0, so let us simplify. 1 by a square plus 1 by c square into, now we know that dou p by dou x is equal to dou square z by dou x square. Its notation is r. We already denoted r. So it is z into r plus p square. P into p is p square. So which is equal to 0. Now we have equation 2 as well as equation 3 as well as equation 4 with us. So we can think to find PDE by using these three equations itself. How we can? Look at equation 2, we have constants a square and c square. Look at equation 3, we have constants b square and c square. Look at equation 4, we have a constants a square and c square. So in equation 2 and 3, c square is common. Now in equation 4, we have 1 by a square plus 1 by c square into zr plus p square equal to 0. Now let me write an expression for 1 by a square, that is constant 1 by a square from equation 4. What we'll get, that is x by a square is equal to, we write equation expression for 1 by a square from equation 2, not from equation 4. Let us write an expression for 1 by a square from equation 2. So how we will get, that is x by a square is equal to minus zp by c square. That means minus 1 by a square equal to minus zp by c square x. So that x from the left hand side of the equation 2 move to the right hand side here, that is c square into x in the denominator. That is 1 by a square equal to minus zp by c square x. This we are getting from equation 2. Okay. Now let us substitute this expression in equation number 4. What we get? That is 1 by a square in equation 4 will be replaced by 1 by a square equal to minus zp by c square into x, that is minus zp by c square into x, plus 1 by c square into zr plus p square equal to 0. That means here c square in the denominator of this one is common, so we will shift this to the right hand side. So what remains? Zp by x is equal to zr plus p square. Let us rearrange by cross multiplication. Zp equal to x into zr plus p square. This is the required PD. If I rewrite, z into p means dou z by dou x is equal to x into z into r. R means actually dou square z by dou x square plus p square. P means dou z by dou x, so whole square. This is the required PD. Now we will discuss how to form PDE by eliminating arbitrary functions. In previous examples, we have discussed how to form PDE by eliminating arbitrary constant. Now in this example, we will be discussing how to form PDE by eliminating arbitrary constants. So example, z equal to f of x square plus y square, form PDE by eliminating arbitrary function. Here f of x square plus y square is function. So as usual, we have to differentiate this equation 1 partially with respect to x and y. What we get? Dou z by dou x equal to derivative of f means it is f dash of x square plus y square into here x square plus y square's derivative is 2x, because we are differentiating partially with respect to x. So other variable we will be treating as constant. So derivative of x square plus y square is 2x. So dou z by dou x is f dash of x square plus y square into 2x. Similarly, dou z by dou y is equal to f dash of x square plus y square into 2y. Now, dou z by dou x means it is p. We have notation. So, p is equal to f dash of x square plus y square into 2x. Similarly, q equal to f dash of x square plus y square into 2y. By using these equation 2 and 3, we can form PDE. How to form PDE? It is just enough to divide equation 2 and equation 3. So dividing 2 by 3. So what we get? P by Q is equal to X by Y. Because f dash from the equation 2 as well as f dash from equation 3 cancel when we divide. So P by Q equal to X by Y. That is Py minus Qx equal to 0 as the required PDE, or Py is equal to Qx. Another example, form PDE by eliminating arbitrary function here. Phi of x plus y plus z comma x square plus y square minus z square equal to 0. Here function is phi of x plus y plus z comma x square plus y square minus z square equal to 0. Here function is not explicitly mentioned, so it is implicit function. So how to solve this type, or how to form PDE whenever this type of function is given? So let us consider given function as equation 1. Now let phi of uv equal to 0, where u is equal to x plus y plus z, v is equal to x square plus y square minus z square. So I have defined new variables u and v, where u and v also defined here. Now differentiate given equation or function phi with respect to x and y using chain rule of the partial differentiation. So what is the chain rule? When we have to use the chain rule, whenever function is explicitly mentioned, like phi of this type of function is given, we have to use the chain rule. Here phi of u equal to 0, even again u is function of xy and v is also function of xy. This time we have to use the chain rule. So let me differentiate phi with respect to x initially. Here phi is function of u, because phi of uv equal to 0. Phi is function of u and v, as well as u and v are function of x and y. So dou phi by dou u, because phi is function of x, and dou u by dou x, because u is function of x, plus phi is again function of v also. So dou phi by dou v into dou v by dou x, because v is function of x. So we are differentiating partially with respect to x. We are differentiating phi partially with respect to x. Therefore we can see only independent variable x only. So dou phi by dou u into dou u by dou x plus dou phi by dou v into dou v by dou x equal to 0, because right side 0. So let me shift one term to the right side. So we get this and we will take it as equation 2. Similarly, we differentiate phi partially with respect to y also. This time we get dou phi by dou u, because phi is function of u and v. So into dou u by dou y. Here we have taken independent variable y. In the previous case, we have taken independent variable x. Here we have taken independent variable y. So dou phi by dou u into dou u by dou y plus dou phi by dou v into dou v by dou y is equal to 0. So let me shift second term to the right side. So we will get this and we will denote it as equation number 3. Now from this equation 2 and 3, we will get the required PDE. How? Because if you see in equation 2 and equation 3, see, dou phi by dou u is there in the equation 2, dou phi by dou u is there in the equation 3 left side. Similarly, dou phi by dou v is there in the right side of equation 2, dou phi by dou v is there in the right side of equation 3. So if you divide this equation 2 and 3, we will get the required PDE. So dividing, what remains? Dou u by dou x by dou u by dou y is equal to dou v by dou x by dou v by dou y. So if you substitute these values, we will get the required PDE and denote it as equation number 4. Now we have to find what is dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. Given u is equal to x plus y plus z. So we have to find what is dou u by dou x. Dou u by dou x equal to 1 plus, because here variable is x, so 1 plus derivative of y is 0. Derivative of z, that is dou z by dou x, which we denote it as p. So dou u by dou x is 1 plus p. Similarly, dou u by dou y, that is 1 plus q. Likewise, we have v equal to x square plus y square minus z square. So dou v by dou x is equal to derivative of x square is 2x plus derivative of y square is 0 minus derivative of z square is 2z into derivative of z is dou z by dou x or p. So dou v by dou x is 2x minus 2zp. Similarly, dou v by dou y, how to find? Derivative of x square is 0, derivative of y square is 2y minus derivative of z square is 2z into dou z by dou y, that is q. So substituting this in equation number 4, we get dou u by dou x, that is 1 plus p, divided by dou u by dou y, that is 1 plus q, equal to right side dou v by dou x, that is 2x minus 2zp, divided by dou v by dou y, that is 2y minus 2zq. If you simplify by just cross multiplying and all, we will get the simplest and standard form of the PDE. That is, I just cross multiplied 1 plus p into 2y minus 2zq is equal to 1 plus q into 2x minus 2zp. So which implies, if you simplify by opening the brackets and all, we will get p into y plus z minus q into x plus z is equal to x minus y, which is the required PDE. Now let me move to next example. Example 3, z is equal to y into f of x plus x into phi of y. So what is the difference with this problem and the previous one? In this example, we have two functions, that is f of x as well as phi of y. In the previous examples, we had only one function. So whenever we have more than one function, we have to find the higher order partial derivative also. So initially we are not aware, so which derivatives we need. So let us find all 5 derivatives, that is p, q, r, s, t. And later we will think how to form the PDE. So given equation, let me take it as equation 1. So first find dou z by dou x. How to find dou z by dou x? We denote it as p. Here function is y into f of x. Since we are differentiating partially with respect to x, y is constant. So y into derivative of f is f dash plus x is variable, phi of y is constant. So phi of y into derivative of x is 1. So p equal to y into f dash of x plus phi of y. Now we differentiate given equation number 1 with respect to y, what we get, see. Dou z by dou y, we denote it as q. Here y into f of x, we are differentiating partially with respect to y. So f of x is constant, y derivative is 1 plus x is constant, derivative of phi of y is phi dash of y. Now we differentiate partially with respect to we'll find the second order derivative. So dou z by dou x, that is equation number 2, we again differentiate with respect to x, so that we will get the dou square z by dou x square. So dou square z by dou x square, it is just enough to differentiate equation number 2 partially with respect to x. So we denote it as r. So in the equation number 2 we have r into f dash of x. If you differentiate partially with respect to x, y is constant, derivative of f dash is f double dash, plus phi of y, it is function of y, so it is constant, its derivative is 0. So r equal to y into f double dash of x. Now dou square z by dou x dou y, we have to find s, that is notation is s, dou square z by dou x dou y. How we will find? Either you differentiate dou z by dou x with respect to y again, or you differentiate dou z by dou y with respect to x again, because dou square z by dou x dou y or dou square z by dou y dou x, both are same. So now let me differentiate equation 2 itself with respect to y. So what we get? Y into f dash of x, here f dash is constant, derivative of y is 1, plus phi of y, what is the derivative? Phi dash of y. So we got s equal to f dash of x plus phi dash of y. Next we have one more derivative, that is dou square z by dou y square. How to find? Just enough to differentiate equation 3 with respect to y again partially. So its notation is t. Derivative of f of x is 0 because we are differentiating partially with respect to y, plus derivative of x into phi dash of y. X is constant, derivative of phi dash is phi double dash. So we got all 5 derivatives p, q, r, s, t. So we have to form PDE by using these all 5 equations. Need not to use all 5 equations. We have to think in some approach and some logic we have to use, and we have to form the PDE. Need not be in same unique way. We can have more than one PDE also, but approach should be proper. See here, how I'm going to approach is here. If you check equation 2, we have f dash of x term, and equation 3, here we have phi dash of y term. At the same time, equation 5 is having only f dash and phi dash term. So I'm thinking to get an expression for f dash of x from equation 2, and to get an expression for phi dash of y from equation 3, and substituting in equation 5. Let me see what happens. From equation 2, I write what is f dash of x, that is p minus phi of y divided by y. Similarly, from equation 3, I write phi dash of y equal to q minus f of x by x, and substitute this in equation 5. So what s equal to f dash of x is this, plus phi dash of y is this. Let us simplify by cross multiplying, that is p minus qy into x plus q minus f of x into y divided by xy. What happens? See, px minus xqy plus qy minus y f of x divided by xy, which implies s equal to, let me simplify by taking similar terms together, px plus qy minus, taken outside, x into phi of y plus y of phi of x f of x divided by xy. Now let me shift this xy with x s. So this is xys is equal to numerator px plus qy minus, look at x phi of y plus y f of x. Look at what is this from equation 1. This is nothing but z. So I'll write it as xys is equal to px plus qy minus z. Or if I write the other notation, xy into s means dou square z by dou x dou y plus z is equal to x into p means dou z by dou x plus y into dou z by dou y. This is all about this video, formation of PDE. Thank you for watching.